Okay, let's get into section 2, chapter 5. This is going to be dealing with direct variation. Now, what's direct variation? If I was to talk about slope, okay, and my slope went up like this, and let's say this slope is at a 512. Let's use that kind of thing like it's a roof, right? 512, right? That means for every 12 inches I go out this way, I go up 5 inches, okay? My direct variation on that is 512. That's what really a direct variation is. It's this number here. It's like a slope. It's what's changing one variable. So if I was going to talk about direct variation, it's this, y equals kx. And my k, now we're not using m in here because it's really not a slope. My k is my direct variation. So if I wanted to map this one, it's y equals 5/12 x. That is an equation of direct variation. Okay, it's over 12 and it's up 5. That's our direct variation. All right. Now, if you have anything else with the direct variation, if you had something, let's say y equals 5/12 x plus 1, this cannot be a direct variation. Well, it's just in this, when we're working with direct variation, all right, and I don't want you to confuse this because we are going to learn eventually the slope-intercept formula, which does look like this, by the way. We're just working right now with direct variation. All right? So if you have something like this, this is not a direct variation. If you have something like this, this is a direct variation. You cannot have, it cannot be added to it, anything subtracted from it. It has to be in the form of a fraction or some number here. It's called a coefficient right here with an x. It has to be in that form. It's just a variable. It's just a variable. The way that works then is if we're going to graph it, not saying we're going to have to graph this in here, but if I was going to graph y equals 5/12 x, all right, and I'm going to graph this, every direct variation has to start out at the origin, 0, 0, right here, all right? If I'm going to graph it, it has to start out at 0, 0. And if we did this, we did our t-chart, and we put 0 in for x, what's our y going to be? 5/12 times 0 is 0. So right away, no, I'm just doing this because I'm showing you on a graph. Okay, so this starts at 0, 0. This then is a direct variation. If I put, let's say, well, I'm going to use a bigger number here. I'm going to use 12. Why would I use 12 in this case? Because if I go y equals 5/12 times 12, what happens to my 12s? They cancel out, don't they? And it leaves me with a whole number 5. So if my x is 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, out here somewhere would be my 5/12. That'd be a representation of that graph. Okay? So it starts, direct variation has to start at the origin, or what I'm saying, you have to be able to put 0 in for x and come up with 0 for y. Yes? You could have 5/3. You could have just 3. 3 would be 3/1. Okay? If you're going to work with that slope, 3 over, if they gave you just 3, then your slope is actually 3 over 1, which means I go over, or I go up 3, and I go over 1. You'd have a slope like that. What's that? What do you mean? No, chances are you're not. Your slopes are going to be, you're going to be able to reduce them to something, yes. Okay, sure. Well, yep. The key to remember on direct variation is you have to get it to an equation of like this. And this here is your coefficient. This can be any number. It doesn't matter. It can be a decimal. It can be a fraction. It can be a whole number. It can be a negative number. It doesn't matter, but you can only have it in this form. That k can be any number. All right? It can be an imaginary number, which you can't graph it. But, all right? Now, so you understand that. That's direct variation. If you have anything on the end of it, let's say 3x plus 1, that is not, it cannot be a direct variation of that form. Okay, y equals just 3x is. And remember, the way you can test this, if I put 0 in for x, my y has to equal 0.
Well, it's pretty much what we did before by subtracting numbers on both sides, but just seeing if it's direct or not, if it has.
What we're going to be doing on this section, now that you know what a direct variation is, you're going to get something like this. 2x plus 4y equals 10. And you have to figure out if that equation is a direct variation. Well, the first thing we can do is we can move our x over, right? So we can say minus 2x here. Remember, it has to be in the y equals kx form. So we have to get y by itself. So we subtract 2x from both sides. And we're left with 4y equals 10 minus 2x. What do we do next? What do we do next? We want to get y by itself. Subtract, divide. Divide 4. We're multiplying by 4, so we divide by 4. Y equals 10 fourths minus 2x over 4. We can reduce this, but are we going to be able to get it into this form? No. No, this would not be direct variation. Okay? If we had it in the form of 2y equals 4x, what will we have to do? Divide by 2, right? This cancels out. Y equals 2x. Is that a direct variation? Yes, it is, because it's in our form. What would be our variation? Not 2x. Remember, just the k is our variation, so 2 would be our variation at that point. What's happening is I'm making a variation from y by multiplying x by 2. All right? So if I put 1 in for x, if I put 1 in for x, my y is going to be 2. If I put 2 in for x, y is going to be 4. It's varying by 2. Well, I'm just showing you. You shouldn't have to. I'm just showing you. If I put 3 in for x, y is going to be 6. My y is varying by 2 each time. That's my direct variation. All right? Any questions on that? We understand what I'm doing there? What a direct variation looks like? Good. All right, let's take a look at, not sure if there's much on the second. Come back to me. No, just more direct variation. Hmm, 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 hmm. I think you can do those. I think you can do those. Suppose y varies directly by x. In other words, there's a direct variation. Okay? Write a direct variation equation relates to x and y. Then find a value of x. So y equals 14 when x equals 2. If I was to draw a chart like this, say x, y, well, my x is 2, this is 14, and we know it's a direct variation. What do you think my variation would be? 7. Why would it be 7? There you go. If I was to divide 2 in the 14, it equals 7, right? So if I set up a direct variation, y equals 7x, do you think that would be true? Would that be true? Yeah. See how I did that? All I did was took my x value, divided it into my y value, and I came up with 7. And I know that's my direct variation. So now it asks, then find the value when x equals 6. Let me clear this out. We have y equals 7x, and when x equals 6, y equals 7 times 6, right? Y equals 42. That would be the answer for number 7. You need to do the other 5. Any questions on this? Nah, I do 13. No, 1 through 13. Skip number 7. Let's take a look back over here. Yeah, all you have to do is determine whether these have a direct variation or not. Pretty quick, pretty easy. Should be able to do that.
So yes or no?
Yes or no. Solve for y on each one of those.